Hi everyone, it's Vlasta from Memgraph, and today I would like to show you new features from Memgraph version 2.7. Probably the biggest news in Memgraph 2.7 is that now it can run in two different storage modes, transactional and analytical. If you've been using Memgraph before, you've been using only the transactional storage mode. That is the mode that favors strongly consistent ACID transactions. It's using WAL files and periodic snapshots. This is very useful when you have concurrent imports, when data is being created, updated, changed in very quickly, and you need to have proper isolation of transactions so that everything in your database is correct. But sometimes you're importing data which is very clean and linear. So you're only creating new nodes and new relationships. And in the transactional mode, it can lead to certain memory spikes because the database is, regardless of the clean import, trying to create and ensure those properties as well. That is why we implemented the analytical mode, where you actually trade this insurance, these ACID guarantees, for more speed and less memory consumption during import. So if you change your mode, your Memgraph mode to analytical, there are no more snapshots created automatically. There are no more ACID guarantees. There are no more WAL files, and there's zero isolation level. So you can use this mode to import your data with using less memory and more quickly. But as I mentioned before, and I'm repeating this on purpose twice, the data really has to be imported, we call it cleanly. So node is created, relationship is created, new node is created, new relationship is created. Then, if you are doing something in production or you're creating an app, you can switch back to the transactional mode and continue developing whatever you're developing and still get those ACID guarantees back. But if you've imported all of your data and now you only want to run analytical queries that only read the data and return a certain result, you can stay in the analytical mode and take advantage of that lower memory consumption. But be careful, if any concurrent changes start to happen, you will have no ACID guarantees. You can take snapshots manually, but they will not be created automatically. So there's a bit of trade-off on both in these modes, so you just need to figure out what works for you and what is your use case. So to repeat, the transactional mode provides ACID guarantees, while the analytical doesn't, but it gives speed and less memory consumption. How do you change between these modes? You don't have to restart the database. You just, in your single session, you just run a query to go to the analytical mode, or then run a query to go back to the transactional mode. So another feature we added in Memgraph 2.7 are the subqueries. The subqueries are independent queries that run inside other queries. And here I have two examples. So this first example on the left is finding players who transferred from and to certain teams and season that happened in. So this is both of these queries return the same result. The difference is this second query is written with subqueries, and you can see here how I started that with the call subquery clause, and then opening the curly brackets and writing another query inside. As you can see, I can pass variables from the top query to the subquery, and also pass results from the subquery to the top query. On the right hand side, I'm kind of clumping two different nodes, two different types of nodes, or nodes with different labels, into a single variable and listing it out. So without subqueries, that query is a bit complicated. It's kind of simpler with using subqueries, where I can easily just merge these two results into a single variable. So the point is, subqueries are now enabled and supported by Memgraph. You can use it or not. It depends on your way of thinking and what's easier for you. And of course, if you're coming from a system that used subqueries and your queries have them, you don't have to rewrite them. They will probably work. So check the documentation on subqueries, as there are slight differences between Neo4j's implementations and ours due to extent of what we offer, but I hope this helps in your transition. Query planners are not always the smartest one in the room. So that is mainly because they're missing some information to make the best decisions and therefore execute the query as fast as possible. This is especially true if you have several properties in your graph which have indexes, and then you want to filter nodes by using those indexed properties. So we wanted to give you an option to make your query planner smarter by tasking it with analyzing the graph and checking out what nodes and properties, what labels and properties you have. So it has those information missing, and it can make better decisions. So to show you what actually happens in the query planner's brain, I've created a short example, a simple example, to see what's actually happening behind the scenes. So to start with, we are creating 6 nodes. All of those nodes have property ID 1 with values 1 to 6, and 5 nodes have also property ID 2 with values 1 or 0. So what would happen until now in Memgraph, or if you're not doing anything and nothing extra, so this is the default path, is if you're trying to match a node which has both properties with value of 1, the query planner would decide to count the nodes that have both of those properties, and then use the property use the less to do the matching. So ID1 is present with 6 nodes, and ID2 is present with 5 nodes. So it would take ID2 because it thinks it will the query will execute faster if the matches are done with ID2. So it checks all ID2s, and when the value is equal 1, it also checks ID1, and when that value is equal 1 as well, it's found a match. In this case, it's this one particular node which has both property values 1. But this is not the most optimal way, because if we go back where we only just created the nodes and created indexes, and then tell the query planner, hey, please analyze the graph, it will not only count the nodes, but it will count the labels and properties and calculate some statistics. So with ID1, it will count 6 nodes and 6 property groups, because each node has a unique value, and then the average distribution would be 1. And chi-square is 0 in that case. And with property ID2, which is present with 5 nodes, there are only 2 property groups, because the only possible values are 1 or 0, and then the average distribution is 5 divided by 2, or 2.5, and chi-squared equals 0.2 in that case. And only then is the matching done, the query is run, and then if the query planner sees, oh, I have to make a match using 2 indexed properties, it will not count the labels, but it will count the nodes, but it will check these values and choose the property which has lower values. In our case, it's the ID1. And as if you can see here, it will only go further in checking the values with the node with ID1 equal 1, because all of the other nodes are dead ends, so no need to check further values. Only ID1, only here is ID1 equal 1, and then it checks the ID too, and it also equals 1. So even though it needed to check 6 nodes in the, let's call it the first level, the second level, the second depth was only 1 node, which equals in matching only, in checking values only 7 times, while here there were only 5 nodes in the first level, but there were 3 checks in the second level, so 8 checks in total. So indeed, this way of checking and making a match is more optimal, and of course this is a very small example with a handful of nodes, but imagine if there were a million nodes here and every second node needed to be checked in the second level. So if you're noticing that your queries are a bit slower, you've placed indexes, you've created indexes, but it's still going a bit slow, give the query planner a bit of resources and a bit of time to analyze the graph, and in return it will give you back that time and those resources even more, because it will be smarter and it will execute the queries faster. This next feature is for those unwanted queries that we clicked run but are not really interested in the results anymore. We want to fix something, or it's taking a bit too long and we want to adjust it. So I'm going to run a bogus query over here, which will just keep on spinning. So we can stop the execution of the queries now with using the terminate query. So I'm going to do a vertical split over here in our user interface, Memgraph Lab, and open another execution window. To terminate a query, you first have to know its ID. So the first query I'm going to run is show transactions. And it will show me 2 transactions. One of those is the actual show transaction, and the second one is this one that keeps on spinning. To stop it, I just need to say terminate and give the appropriate ID, and it's terminated. If you like to build your own procedures inside query modules, you can also terminate those, but you have to have a function that allows the engine to terminate them. So let's pop into our query modules for a bit, and here I have one Python module with a procedure that it's running in an infinite loop. So you need to have this line where it checks if it must abort, and to get that nice message that it has been aborted, you need to add this line as well. So let's see what happens when I run this, and how do I stop it. It's actually just the same. So let's add another vertical split. So show transactions. Here are my transactions, and then terminate. I'm really bad at talking and writing. And you terminate it. If you are a user in a user group, be aware that you can only see and terminate your own transactions. And if you're an admin, you can of course see and terminate all the rest of the transactions. That's the terminate transactions feature. So up until now, Memgraph was using only one password encryption algorithm, bcrypt, and we wanted to give you an option to choose the password encryption algorithm, because bcrypt wasn't really good at handling concurrent authentication. So it's the most secure algorithm. It handles brute force attacks really good, but it was just slow when you were trying to connect to the database from several sessions. So now with this configurational flag, you can also choose to use SHA-256, which is a bit less secure, secure, but it handles the concurrent authentication very well. And if you want to be somewhere in between, so a little more security than the regular SHA-256, you can use the SHA-256 multiple, which is a bit slower, but is also more secure than SHA-256. And at the end, one more improvement and a couple of bug fixes. So as you probably know, we've already done some work on the load CSV clause to make the import faster. And in this release, we also have one small improvement regarding the load CSV clause. So now it's a bit faster as well. And we've also fixed the all shortest paths algorithm, so it's all shortest paths, not one. I'm missing an S here, and the algorithm now supports multi-edges. And if you're a user with a global visibility on the graph, you will be happy to hear that you will no longer be slowed down by unnecessary checks of privileges, because you can see the whole graph, so there's no reason to check if you have privilege on the nodes. And that's it for this release. Thank you so much for listening, and if you liked what you heard, then head over to memgraph.com download the newest Memgraph version 2.7. Everything I've talked about is described in the documentation, and if you have any questions or you need help, join us on Discord and we'll try our best. And that's it. See ya. Bye.